So like I said in the previous video, in this section, we're concentrating on vectors from a geometric perspective, and then we will revisit the same concepts, but from an algebraic perspective in the next section. So on page 2, we are going to talk about how to add two vectors geometrically. Okay, so the sum of two vectors is also going to be a vector. It is called the resultant. Okay, you need to know this word because it's going to come up throughout this section, especially when we do application problems. If you add two vectors, the vector that results is called the resultant vector. Okay, keep in mind that vector addition is commutative. Okay, that means that order doesn't matter. Meaning if I add vectors u and v, if I do u plus v to get a new vector, I'm going to get the same vector if I do v plus u. Okay, so order does not matter. There are two ways to find the sum of vectors a and b geometrically. Okay, so here we go. I'm going to talk about both methods and then I'm going to illustrate each one. Okay, so the first thing you're going to do, and again, we're dealing with two vectors here, a and b. Okay, it says place the initial point of vector b at the terminal point of vector a. The vector with the same initial point as a and the same terminal point as b is the sum a plus b. Okay, you might have to read that again. Okay, it's a little confusing. But basically what this method 1 is saying, if you're doing a plus b, you're first going to graph out vector a. And then at the terminal point of vector a, you are going to place the initial point of b. Okay, and then you would just graph vector b. Okay, and then the sum is going to be the vector that has the same initial point as a and the same terminal point as b. Okay, the second method is the parallelogram rule. Okay, so if you remember what a parallelogram is, it's something that looks like this. It's a shape with four sides, and each opposite pair of sides is parallel. Okay, so like this side is parallel to this side is parallel to this side. Okay, so what the parallelogram rule says, you need to place vectors a and b so that their initial points coincide. Then complete a parallelogram that has a and b as two sides. The diagonal of the parallelogram with the same initial point as a and b is the sum a plus b. Okay, again, you may have to read through that again. Okay, but essentially what you're doing in method 2 is you're going to graph each vector. Okay, so you're going to graph A, you're going to graph B, but you're going to graph them so that their initial points are the same. They have the same initial point. And then from those two vectors, you're going to make a parallelogram. Okay, and then the diagonal that starts at the initial point is going to be the sum. Okay, so I will go back through these instructions as we graph this example. Okay, in example 1, we're going to try this out. Okay, so let me show you what we have. We have vectors u, v, and w, and we're going to be using these same three vectors throughout the next few examples. Okay, so this is what they look like. Okay, they are on a grid scale so that you can graph them accurately as far as the magnitude goes. Okay, so given these three vectors, you're going to have to, graph the vector that you're asked for. So right now we're going to be working on addition, but then we're going to move on to subtraction, and then there's something called scalar multiplication. We're just going to be doing various drawings of these combinations. Okay, so for example 1, like I said, we're going to be doing addition. If you go down to the bottom of the page, I have a grid set up so we can do the addition using method 1, and then there's a grid next to it so that we can do the addition using method 2. Okay, you're going to see that no matter which method we use, you should get the same resultant vector. Okay, so let's give this a shot. Okay, let's read the directions first. It says, example 1, use the vectors illustrated in the figure to graph the vector u plus w using each of the methods described above. Okay, so we're doing u plus w. Okay, addition is commutative, so if you wanted to do w plus u, it's going to give you the same thing. But I'm just going to stick with the order here. Okay, I'll do u plus w. Okay, so we're not going to be worried with v here. Okay, so let's go back to method 1. Okay, so method 1 is the one where you're going to place the initial point of the vector, or sorry, you're going to start with the first vector, you're going to draw it out, and then wherever that vector leaves off, that's going to be the initial point for the second vector. And then you will draw that vector in, okay? And then the sum is going to be the vector with the same initial point as the first vector and the same terminal point as the second vector. Okay, so let's try this out. Okay, so the first thing I would do is graph out vector u. Okay, so when I look at vector u, I've got to make sure it has the same magnitude and it's got the same direction. Okay, so remember, we count boxes to do this. Okay, so here's my initial point. I need to go down 1, right 2. Okay, so that's how I'm going to get vector u. Okay, it doesn't matter where you start. I'm probably going to start in the same place on both boxes so we can compare the results. So, okay, let's say that I am right here. Okay, so again, I need to go down 1 box and then right 2. Okay, so down 1, right 2. Okay, so here is my vector. This is u. I'm going to connect these dots and I'm going to put the arrowhead on here. Okay, I need to draw from the initial point to the terminal point. Okay, so this is vector u. Okay, at this terminal point, this is going to become the initial point of w. Okay, so I'm going to put w in another color. Okay, so w, we're going to have to draw it. It's got to have the correct size. It's got to have the same direction. So from the initial point, we go 2 boxes to the right and then up 1, 2, 3, 4, 5. Okay, so I'm going to do that. Okay, you're going to put this vector, okay, its initial point is going to be where you left off. Okay, so now I need to go 2 to the right and up 5. Okay, so that's going to be here. So this is going to be the terminal point of w. Okay, so again, I'm going to connect these 2 points, and I've got to put the arrowhead on there to establish the direction. Okay, so here's my direction. Okay, and now that I have this, I can draw the resultant vector. I'm going to put that in red. Okay, to draw the resultant vector, it's going to be the vector that has the same initial point as the first vector and the same terminal point as the second vector. Okay, so it would be this red vector. Okay, you do have to put a direction on it. Okay, so you're drawing from the initial point to the terminal point. So the arrowhead needs to go on the terminal point here. Okay, so this is going to be the sum u plus w. This blue vector, let me go ahead and label it. This was just w. Okay, but that's what the summation looks like. Okay, so now I'm going to put this, I'm going to try the same exact thing with the other method. Okay, and you're going to see that we get the same resultant. Okay, so for method 2, we're going to use the parallelogram rule. So we're going to draw both vectors, but we want their initial points to coincide. Okay, so let's go ahead and do that. I'm going to use the same colors. Okay, and I'm going to try to position this in the same place that I did with the other with method 1. Okay, so I'm going to stay at this level and I'm going to go 4 boxes in. So 1, 2, 3, 4. So this is going to be my initial point. Okay, I'm going to draw vector u. Okay, so I know for vector u, I need to go down 1 and right 2. Okay, connect my dots, put my arrow on it. We're always drawing from the initial point to the terminal point, so that's vector u. Okay, the difference with this method, or one of the differences, is that I'm going to draw vector w now, but it's going to start at the same initial point. Okay, so this is also going to be the initial point of w. And we know to construct w, we need to go right 2 and up 5. Okay, so right 2, up 1, 2, 3, 4, 5. Okay, so I'm going to draw in vector v. Okay, I'm drawing from its initial point to its terminal point. Okay, all right, so it's going to look like this. Okay, so this is vector w. So at this point, you have to form a parallelogram. Okay, so if you go back up here and read, it says complete a parallelogram that has the two vectors as sides. Okay, so we've got to turn this thing into a parallelogram. Okay, well, you need to be really accurate when you do this. Okay, so what I'm going to do, okay, I'm going to draw in a second blue side. Okay, so we know for the blue side, you need to go right 2, up 5. Okay, well, where is that blue side going to be? It's going to be parallel to the first blue side. Okay, so it's going to begin at the terminal point of U. Okay, so I've got to go right 2, up 5. So that's going to be this point. Okay, so this other side of the parallelogram, the blue sides, are going to look like this. Okay, so that's the blue sides are the same size and they're parallel. Okay, so if we've done this correctly, and we have, okay, we should be able to just connect these 2 points. Okay, and then we'll have that the green side is parallel and the same size, and you can check it. If I start right here, I have to go down 1, right 2. Okay, so this is our parallelogram. Okay, we have constructed it. Okay, so now that we have the parallelogram, we just draw in the resultant. Okay, the resultant is the diagonal of the parallelogram with the same initial point as the original vectors. Okay, so if we come down here, and I'll put the resultant in red, remember the initial points of both vectors, it was right here in red. Okay, so we're going to start there. That's going to be our initial point, and we're going to draw the diagonal. We're drawing straight to the opposite point. Okay, so this is going to be the terminal point right here. So what's in red is vector u plus vector w. Okay, so it may look, if you look at the 2 pictures, they look a little different because one's got a parallelogram on it. Okay, how do I know I came up with the same resultant? Okay, well, count. What is the size of your resultant? Okay, remember, we're in a grid system here. Okay, I don't have an XY plane attached to this thing, so it doesn't exactly matter where the initial point is or where the terminal point is. What matters is the size and direction. So if I look at the first red vector, the resultant I got from method 1, if I look at I'm concentrating on the red vector. If I start here at the initial point, to get to the terminal point, I need to go over 1, 2, 3, 4 units to the right and up 1, 2, 3, 4. Okay, so I go 4 to the right and 4 up. Okay, and we're pointing in that direction. Okay, do I get the same thing from method 2? Okay, well, look at the red vector. It's the resultant. So start at the initial point. We have to go 1, 2, 3, 4, and then up 1, 2, 3, 4 to get to the terminal point. And it's pointed in the same direction. Okay, so just by counting that out, I know I have achieved the same answer. Okay, so both methods do produce the same answer. Okay, you will probably, as you practice this, you will probably develop a preference from one method over the other. My personal preference is method 1. The book and my math lab tend to push method 2, but you really have to stick with what works for you because both methods produce the same result.